3.4, solve systems of linear equations in 3 variables. What's going on? Seems like freaking out. So I'll have 3 equations, 3 unknowns, and so occasionally you will be able to solve them with a substitution like method, because they'll just start you out with like something that's really easy to solve for one of the variables, but usually elimination is the better option, and that would be my preferred method until we get to something later in the chapter and I teach you a much easier way to do it. So, but you got to learn the hard way first. You got to suffer a little bit first before we give you the easy way. So,
I just don't remember what it was.
huh?
It was like a saying, something about how, like, you gotta suffer before you get the easy stuff. I can't remember what it was. You gotta suffer before you get the easy stuff.
So, much like with the last section when we said, or not last section, the section before that, but when we said you need to like check the numbers back in, it's even more important when you have the 3 equations and 3 unknowns that you check them. So the first part of this is actually to just check them, okay? Now, as soon as you get one that's a no, you can stop. But if you have yeses, you need to check all of them, okay? Like if you get a yes, like, okay, it worked in that equation, you need to check it in another one. Because a lot of times what happens is it'll work in like 2 of them and not the third one. But as soon as you get a no, it's a no. You don't have to keep going. So, number 4, the ordered pair that we're going to be trying is -1, -2, and 5. And the 4 equations are 4x. What is happening? This thing is like completely spazzing. 4x minus y plus 3z equals 13. X plus y plus z equals 2. And x plus 3y minus 2z equals -17. So we're going to go and we're going to work our way down, plugging those numbers in here and solving. The left side should equal the right side when you're done. Okay, so don't do anything to the right side. Just keep that. Just work out the left side. So I'm just going to go down in order. 4 times -1 minus -2 plus 3 times 5 equals 13. So this is -4 plus 2 plus 15 equals 13. So 13 equals 13, so that one works. Then let's do the second one. So you've got -1 plus -2, so -2 plus 5 equals 2. So that leaves us with 2 equals 2, so that one works. And then the last one, -1 plus 3 times -2 minus 2 times 5 equals -17. We got -1 minus 6 minus 10, -17, so -17 equals -17, so that one works. So this is a solution. So let's look at another one. Number 6, -5, 1, 0, and we have the equations 3x plus 4y minus 2z equals -11, 2x plus y minus z equals 11, and x plus 4y plus 3z equals -1. So I'm just going to work my way down through them again. So 3 times -5 plus 4 times 1, so just 4, minus 2 times 0 is equal to -11. So -15 plus 4 is -11 equals -11. So that one works. The next one, we have 2 times -5 plus 1 minus 0 equals 11. So that's -10 plus 1 would be -9 equals 11. That is not true, so this is not a solution. And we can stop there. We don't need to do the last one because even if it works, it does not matter. It has to be a solution to all three. And I'm going to warn you, these problems do take up at least half of a page pretty much every time. Just the nature of the problem. So I get like 1 a page in my thing. So and it all depends on how you do them. Like I a lot of times will do like a little bit and then I'll like go to another column on that, so I don't take up so much. Yeah. They still take up a lot of space. All right, so solve the system using the elimination method. So number 10, we've got 2x minus y plus 2z equals -7. We got -x plus 2y minus 4z equals 5. And x plus 4y minus 6z equals -1. So much like the problems we were doing the other day, we want to find one variable that we can cancel, but we're only canceling it out of 2 of them. Okay, we're not canceling out of all 3 initially. So what I always do is I like to go ahead and find a variable that either is already opposite or something that I can easily multiply by something else. The x's? Okay. So yeah, so I can do that. So these 2, I like to mark off which ones I'm doing first because you're going to have to do it twice and you cannot pick the same one twice. So you'd have to pick another one and you're going to have to cancel the same variable. Okay, so when you go to do it, because we're trying to get down to 2 equations and 2 unknowns is what we're working for. So when I have these 2, that gives me, canceled out. I'll do this in red and then I'll switch to the other color. So those cancel, so I'm left with 6y minus 10z equals 4. And then I still need to cancel x, but I need to cancel it from 2 different ones. Okay, so which one do you want to do with the top one? That's going to have to be the top one with something. And remember, it needs to be something that has opposite sign or opposite number. Okay, the middle one. So then I like to bracket off on the other side and show what I need to do. What do I need to multiply by and which one to get it to cancel? Middle one by 2. So that's going to give us, and a lot of times I like to rewrite it off to the side if so that I can cancel it. So I rewrite the top one. So then I have -2x plus 4y minus 8z equals 10. So remember, when we multiply that 2, it's going by every single thing in there, not just the left side. So when those cancel, I am left with 3y minus 6z equals 3. So I come down 3y minus 6z equals 3. So I have them stacked. Now I have 2 equations and 2 unknowns. Okay, so this is, once you've done that part, you're back to 3.2. So what do I need to do for these, something in here to cancel? multiply the bottom by -2. So I now have 6y minus 10z equals 4. -6y plus 12z equals -6. So then I have 2z equals -2. So z equals 1, -1. And I a lot of times will circle whatever I got so that way I can go back and find it because we have to write our answer as an ordered triple. So in the other section we had to write it as an ordered pair. This one's an ordered triple in the order of x, y, z. So now that I have found z, I take it and I plug it back into one of these two equations. Okay, again, we would want to use the original because it's going to be easier if we're going to use the one, if we manipulated one. So which one do you want to use, the red one or the blue one? The blue one? Okay. Focus it in so it's a little clearer. So then 3y minus 6 times -1 equals 3. So 3y plus 6 equals 3. 3y equals -3. Y equals -1. So then once we have those two, we go all the way back to one of the three original equations. Doesn't matter which one, and we plug it in and solve for the missing variable. You want 1, 2, or 3? It doesn't matter, just purely your, 3. Okay, great. So I've got x plus 4 times -1 minus 6 times -1 equals -1. So x minus 4 plus 6 equals -1. X plus 2 equals -1. So x equals -3. So then my answer, written as an ordered triple, would be -3, -1, -1. Thanks. And you can go back and check it like we did in the first problems, but I'm not going to go through and check all of them here. I would recommend on a test or a quiz that you check them to make sure that you get them right. Blows my mind sometimes how many people won't do that. It's like, then they get the problem wrong. They're like, why did you get the problem wrong? Well, I don't know. If you had checked it, you would have known it was wrong. Like, sorry. So annoying. Like, same thing with factoring. I'm like, check it. Just check it. You can always check factoring. No, I don't feel like it. Well, then you must not feel like getting an A. That's my thing. Okay. Let's do another one. Any questions about this one? They're not really any harder than the other ones. They're just long. So it's like you do like 3 problems and you're like, I feel like I've been working for 2 hours. Like, it's just, they're so long. All right, number 12. We've got 4x minus y plus 2z equals -18. We've got -x plus 2y plus z equals 11. And we got 3x plus 3y minus 4z equals 44. So, when you're doing the 3 equations and 3 unknowns, okay, the last one, it was pretty easy because the x values were all, right there. They were pretty easy. When I go through to pick what I'm going to do with these ones, you can technically pick whatever variable you want, okay? I try to find the one that is the easiest to just multiply, like, one of them by, if possible, and if not, then obviously you're going to have to multiply both of them. So I would look at all the variables stacked and say which ones are going to be the easiest to deal with. The z's. Okay, so yeah. And you can pick whatever you want. I've had some people pick the absolute hardest variable that there is, and I'm like, why did you pick that one? I don't know, it looked cool. Okay, well, it's the hardest one, but be my guest. So, let's do the z's. So, which two do you want to do first? And also, just really quick, going back for clarification, you can do like 1 and 3. You don't have to. They don't have to be like touching or something. Just FYI.
1 and 2.
1 and 2? Okay. So what am I going to need to multiply by in which one?
Middle by 2.
Yeah.
Positive
Negative.
2? Negative 2. Okay. So I'm going to multiply this one by negative 2. So I'm going to have 4x minus y plus 2, oh, nope, come back, 2z equals negative 18, and then multiplying this one by negative 2, I'm going to have positive 2x minus 2y minus 2z equals negative 22. So my z's are going to cancel. I'm left with 6x minus 3y equals negative 40, right? Yeah.
The middle equation started out with a 2y. That would make it negative 4y.
Thanks. I was most definitely looking at this one. This is what happens on 3 hours of sleep. Okay, is that, wait. This is negative 5y. Is that right now?
I think it would be negative 4y. Oh wait, never mind. After adding.
Yeah.
Yeah.
Okay. I was like,
I didn't get any sleep either.
I'm so tired. It's like not even funny. I'm like, after tonight, I think I'm gonna actually go home and crash tonight. Oh no, wrong color. How in the world did I definitely grabbed the other color?
I like how whenever we say it's like it's so bad it's not even funny, but we're all laughing about it.
That's what I do when I'm tired. I just laugh like everything.
All day every day.
And without end, like I will just start laughing and it's over. It's done for. Okay. Well, now that we have that situated, all right, which other two do you want me to pick now?
First and third.
First and third. Fantastic. All right, what do I need to multiply by and which one?
Top one by 2.
Top one by 2. Okay, let's see if I can do my math right this time. I'm going to do it over here to the side. Okay, so I have 8x minus 2y plus 4z equals negative 36. And then copy down the other one. Negative x plus 2y.
Are we doing the third one?
We're doing.
I'm sitting here like, well, the y's are canceling, but that's not helping me with anything. This is going to be a really long day. I can already feel it. Okay, the third one, copying it down, 3x plus 3y minus 4z. What is happening? Minus 4z equals 44. Okay, z's cancel. So I'm left with 11x plus y equals 8. Yes. Okay. So I'm going to move it down here and stack it. So I have 11x plus y equals 8. Now what do I need to do to cancel something?
Multiply at the bottom one by negative 5. I mean by positive 5.
So the bottom by 5. So we have 6x minus 5y equals negative 40. And then we have 55x plus 5y equals 40. So I have 61x equals 0. So x equals 0. So then I take it and plug it into one of the original ones. Do you want blue or red? Red, okay. So 11 times 0 plus y equals 8. So y equals 8. And then we're plugging into one of the original ones. You want 1, 2, or 3?
2.
2, okay. So 0 plus 2 times 8 plus z equals 11. So 16 plus z, equals 11. So z equals negative 5. So then order triple, 0, 8, -5.
So why are we gonna take 2 days on this?
Do you feel like you need to see another elimination one? Or do we feel like we're okay? I'm okay with doing it if we need to, but if you're like, nah, we got it.
So for whenever we're doing like,
So like on this one, we were plugging back in the x. We just choose one of the, instead of choosing from like one of the original 3, we choose from the 2 we used.
Yeah, so when it's the first variable you've solved for, you're going to solve for the other one with the 2 equations, 2 unknowns that you found.
Okay.
So you can plug it into your modified one if you're just like so ambitious, but your modified one's going to be a lot bigger than your original one. Now, I used to have a teacher who would actually teach that rather than multiplying them by like for this one, like we multiplied by 5, they would have said to multiply the top one by 1/5 and end up with fractions, and that was absolutely miserable. Like if it cancels out like all kinds of stuff, it's fine, but like in that case it would have been miserable.
Yeah.
And I'm like, I would never like teach that way. Like, yes, you can do that, but I just wouldn't. But yeah, so plug it into one of your 2 original, like your 2 equation, 2 unknown originals, and then once you solve for the other variable, then you're going back to the 3.
So yeah.
So your first thing is done with the 3s, and then the last thing is done with the 3s. The other stuff is done with the 2s. So are we okay on? Yeah, I know. That's why I was like, we're okay. So, I will also tell you that on occasion, these can come out to give you no solution or possibly infinitely many solutions, but typically we only have a no solution. You don't really see the infinitely many with these. I don't think any of them in the book actually come out to be infinitely many. So yeah, just no solution is a possibility for you to see. Substitution. Some of them say to specifically solve by substitution. I would tell you that I would not solve by substitution. Unless they give you one like, well, I'll just save it for tomorrow. But if they gave you one that has several of the variables like already like kind of by themselves, in the sense that like you have like x plus y, or today's chapel day, x plus y plus z, like then you can move this stuff over and then you can replace x in one of the other equations with your y and z, and then you cancel down. But there's a lot of steps to substitution, so I probably would refrain from that. So anyways, but we'll do like 1 or 2 more examples tomorrow of the ones that are substitution that could be done that way, or we might just do them by elimination. And I'll try to do one maybe that's no solution as well, so you see what that actually is going to look like.